All right. So we're talking about nth roots today, and we've done a lot with square roots and squaring numbers. Those are inverse operations. So we know that the if I say like the square root of 25 equals 5, what would be like the equivalent equation as a power? Equals 25. So that this is the connection that we make with square roots and squares, right? We're going to go to other powers besides 2. And if I had put a number inside here, a little number inside here, it would be a 2. If it's invisible, it is a 2. Just like the coefficient of 1, we don't always write that for x. 1x is x. It's understood to have a 1 there. This is understood to have a 2 in here. All right? All right. So, x to the third equals 64. Well, let me show you something here. 4 times 4 times 4 is equal to 64. All right? You guys filling in your sheet here? We're going to fill out this table a little bit. And how we would state this in words is the cube root. Now this could also be the third root of 64 is 4. And if I'm going to write that, I'm going to put the little 3, the cube root. Now if it's not a square root, you've got to have the number. The cube root of 64 is equal to 4. So do you see the connection here and here the same as the connection was here and here? Okay. So we do it with cubes. What power are we dealing with here? Fourth power. Yes. Now I'm going to just write it whoops. You said fourth. X to the fourth power is equal to, all right, let's take that out. I forgot about that. Put 625 there. That was the first mistake of the year. X to the fourth equals 625. All right. Now here, I don't have a special word for, like third I had cube, for second I have square root, but I don't have a special word really for fourth power. So I say the fourth root of 625 is 5. And so my index, that little number there, is going to be a 4. The fourth root of 625 is equal to 5. See the equivalent parts here? All right. Anybody want to help me kind of put what we should? 2 is a fifth root of 32. What are we thinking there? For this box, Ronan? Okay, good. I got 5 of them. I think you said 5. Equals what? 32. It does. And we could take it from here, although you got to be careful because sometimes somebody didn't put the right number in. But, okay, so x to the fifth power is 32. 2 times 2 times 2, so x is 2 here, right? Is one of the things we could have. Now, when we write the root, we'll put the fifth root of 32 is equal to 2. So far, so good? These are all specific cases. We have a general case I want to do here. Now, I'm going to take A times A times A times dot, 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 and I'm not telling you how many A's are in that dot. I don't know. Well, I don't have a specific answer for that. Is equal to B. What I do want to say is, here I had 5 factors of 2, here I had 4 factors of 5, here I have 3 factors of 4, right? I'm going to say I have n factors of A. I'm going to use a variable, because for the part I don't know. All right. Anyone want to take a shot of this? What would go in place where 2 is here in this scenario, Trey? You're on a roll here. A is what? I'm going to say, and since I said there's n factors, an nth root, and that kind of goes with our title of our lesson, doesn't it? Is an nth root of B. Very nice. So when I draw my radical, I'm going to put an n in here, right? The answer is B, and that equals A. Everybody got the table filled in? So far, so good. That's just to get us to understand the connections of what these roots are asking for. If 4 times 4 times 4 is 64, the cube root of 64 is 4. All right? So, this little number inside this nook for the radical sign is called the index. So vocabulary here, guys. That little number is the index. This is and I use, this is a radical sign. This thing right here is just the radical sign. And that number inside the radical is called the radicand. Okay. Now, we're going to work on our thing a little bit here, but I have some steps here for simplifying radicals. Okay. First thing I'd like for you to do is do the prime factorization, which is, a lot of times what I think of is we make factor trees. Do the prime factorization of the expression under the radical, or the radicand. Take the prime factorization of the radicand. 2. Take a factor outside of the radical if its number of factors match the index. This number right here. Or the root. Same thing. And then simplify outside and inside the radical. You're going to have stuff on the outside, you have stuff on the inside. You simplify. Most of what we do today will not have much inside. We're going to save that for a little later in the week. All right? We're simplifying radicals. So, examples. Let me start with a square root first. Example 1. Let's take, I got a plus or minus square root of 100 y to the, now I'll leave it y to the 6th. Okay. Now, I said do the prime factorization. What times what's 100? 10 times 10? Let's break down 10. 5 times 2, both ways, right? And those are all prime. Okay. Now, I am going to go 2 times 2 times 5 times 5, and then y times y times y times y. 1, 2, 3, 4, 5. I need a sixth one here. All right? What is my index in this problem? If it's not written, it's understood to be... What's your second answer, Caroline? What's your third answer, Caroline? Okay. Was this here initially? Okay, it wasn't, right? But it's understood to be there, right? So the understood value inside is 2. Okay? All right. So we need the number of factors to match the index. I have 2 2's. So I'm going to put the plus or minus here and bring a 2 out. I have 2 5's. I'm going to bring a 5 out. Here I have a pair of y's, right? I'm going to bring a y out. Here I have another pair of y's. By Maria. I'm going to bring another y out, and here I'm going to bring another y out. And notice everything is circled here, right? So I got plus or minus 2 times 5 is 10. Y times y times y is y to the third. Is that clear? I do kind of want to show an alternative way. If you don't want to expand it, especially if it gets really long, a really big number, really high power. Is everybody good that 100 is 10 to the second power? Are you good with that? And if I write y to the third and then put a square out here, that's y to the sixth power, if you multiply exponents in this case. So we have, if I do the plus or minus and square root of 10 squared times the square root of y cubed squared, what do the square root and squares do? They are inverse operations. They cancel out. So that leaves me with the 10. And the square here and the square root here cancel out, and that leaves me with the y to the third. That's an alternative on these. You see how that could be shorter than this? This might be a little simpler, but longer. This one is may be a little more efficient in the way it's doing it, but it may not be quite as simple. All right, let's do another one. I have a negative, and then I have a radical, and I've got 49 u to the 8th, v to the 12th. So, do you really want to write out all those u's and all those v's like we did here? No. So do you want to kind of go this approach then? Yeah. All right. Well, here's what you'll have to do. Negative square root. How can I write 49 as a square? Jonah?
7 times 7.
Okay. So you guys agree then. All right. I was just getting 2 answers. All right. All right. Now, I'm going to save it, but I want a second power. What needs to be inside parentheses, the exponent inside parentheses with u here? Logan? I need u to the 8th. I got the second power out here. What do I need in here? Well, it is one of those. You're right. And you do multiply exponents here. So 4 times 2 does give you 8. Okay, that is correct. I don't have a power here, but I want to have a second power out here. My A, what do you think? I need B to the 12. I've taken the second power out here. It would need to be a 6. Absolutely right. So we got negative square root of 7 squared times square root of u to the 4th squared times square root of v to the 6th squared. What do the square and square root do? Cancel. So bring your negative. The 7. What's this one going to be? Caroline. U to the 4th. What's this one going to be? Catherine? I'm going to change those around. V's the base, v to the 6th. All right? The 2 and the square root cancel out. The power of 2 and the square root cancel out. The square and square root cancel out. All right? Any questions on that? All right, are you guys running out of room? Yeah. I need a couple more examples because we've only dealt with square roots here so far. I want to deal with some of those other roots as well. So if you could, do you have a piece of paper somewhere near your notes where you can write a couple more examples? Yeah. Okay. All right. Well, actually, the next one is kind of a square root still. But I want you to see something on this one. I have an expression. Okay. Make double parentheses, put y minus 6 in the inside. I'm going to leave a space. This is a square root, right? So I want a second power here. What power is here? Sean? It is. What cancels out here, Sean? And which power? The second power. Square root and the second power cancel out. So all we're left with is the y minus 6 to the 4th. So the expressions, you can't, the big thing here, I don't want you splitting up the y and the minus 6. They're together. They're a chunk. They stay together. All right? And now let's deal with some other powers. I'm going to take the 4th root of 16 g to the 16th h to the 24th. I am really glad you guys don't want to write out all those factors of g and h. That'd be 40 letters that we'd be writing. All right. Okay. But I need powers of 4 here. 16. First of all, let's break that up a little bit. What times what's 16? 4 times 4 is 16. And 4? Okay. And those are so that's 2 to the 4th power. And why is that a good thing here? Put 4 in your index there. Why is that good that we're seeing that? That's matching. We can cancel. Okay? We want to match to a 4th power. So I'm going to take G. I'm going to leave this some space to write a power here. And I'm going to write the 4th power out here. What goes inside with the G? I'm not doing the H yet. I'm taking 4, so what do I want to put here so it's still G to the 16th? 4 here. That is correct. And I'm wanting to work along the same lines with the H. But I need a number in here. Ronan says 6. All right. I'm going to split it into 3 parts. 4th root of 2 to the 4th times the 4th root of G to the 4th to the 4th times the 4th root of H to the 6th to the 4th. 4th root, 4th power, 2, right? 4th root, 4th power. And then really doesn't even matter which one I'm going to have G to the 4th. 4th root, 4th power, H to the 6th. Is everyone good with that one? Okay. All right. Square root of negative 16y to the 4th. Okay. Is that going to be real? If this is even index or square root, it's not going to be real. Okay? We're going to keep it real for right now. Okay? Now, I do want to give you another one. Cube root of negative 8 y to the 3rd. Cube root of negative 8 y to the 3rd. Okay? We can do this. Negative 2 to the 3rd power is negative 8. So the cube root and negative, so that's negative 2, and the cube root of y to the 3rd is y. All right? So that's doable. All right, one more. Nah, I'm not going to do one more. Okay.